Hello class, George here, and unfortunately I'm feeling really under the weather today, so tonight's lecture is going to be a online video lecture instead of the usual in-class one. We're going to be covering the material we had in last class as well as additional material so that we can start not only writing to a Canvas object, but also creating our own basic game engine that we'll continue to work on as we progress in the class using things like sound and so forth in future lectures. Today we're mainly going to just focus on drawing different objects onto the canvas, setting things up, and potentially single touch and clicking on different objects and so forth that you might generate in your scene, as well as some basic design principles and how we're going to approach creating our game engine. So let's go ahead and start. By the way, if things look a little bit different, that's because I did just upgrade to version 3.0. I know I told you not to last class. Feel free to if you want to at this point, because I'm going to be working with this version from here on out. So let's move Android Studio off to the side and actually begin just with the lecture stuff. And then I'll jump back and forth with the project as we move on. So this is more of a refresher from last week than anything else. I'm not going to spend a huge amount of time going over this, but I am going to code some of this stuff so that you at least can watch, go along with it, and have something up and running for the next class. All right, we had talked about how we can manage the layout of the activity using the Android screen orientation. And with sensor landscape, it doesn't matter if we rotate it 180 degrees, it does not cause our device to reset its settings, and therefore our app does not get destroyed. But the user has the ability to completely rotate things around. So why don't we go ahead and actually create that Android app since we're already doing things. So let's go to start a new Android Studio project. My application, I'm just going to call this Game Engine 101. Everything else looks fine. We're not going to use C++ or Kotlin. Hit next. I'm going to go with Android 17 and above. That's what we've been doing so far in the class. Everything else doesn't matter for what we're dealing with. Hit next. And we are going to work with it completely empty. You can leave it as main activity and activity_main for right now. Go ahead and let Android Studio do its thing in the background. All right, so now we have our project open. Let's expand this a little bit and let's go to Edit or File, and let's go to our settings. And I need to make sure that I can actually scroll up and down the text. Here we go, change font size with the zoom, hit OK. And now you all can see what the heck I'm doing. So let's go to App and Manifest, double click that real quick. Now that we have that, we can add to our particular activity this line right here about screen orientation. So let's go ahead and do that. So here's our activity right there. Let's make a space and let's do Android : screen orientation is going to be equal to sensor landscape. Great. Save that. Let's move that off for now. Now the next thing we need to do is make sure that our activity is using a theme that has no title bar and is completely full screen. At present, by default, we're using app compat activity to be as back compatible as possible. If you would like to continue to be as backwards possible, I have provided below the code you need to actually make it so that you define your own style inside the style resource. So let's go to resources and values and styles. And here you can see you can define your own style right in here. You would go ahead and add this one to it, and then you would invoke that style inside of your manifest. Now we're not going to be doing that. I'm just going to actually go ahead and use the activity class. So let's go with activity for no other reason than just to make things quicker and easier. So we have activity. Now all we need to do is make sure we invoke a style or a theme that allows us to actually have things with no title bar. So under here, under activity, above that, you see we have theme. So let's do at Android : style / theme dot no, dot no, let's see if we can just find it, no title bar dot full screen. There we go. Save that now. And what we should notice is, let's go ahead and create our emulator and see what it looks like. So here we go. Let's go ahead and hit OK. And what we should notice with our app is that it's going to fill the entire screen and just have a single bit of text in the center because that's what the default layout, if we look at that really quick, has. So here's our layout, and you can see it right there. And there's our activity. Rotate that, and you can see it right there. Perfect. Let's move that out of the way and continue on. Views 101. What we need to understand here is that our activity plus the user's focus requests the layout to be drawn for the first time. Another interesting thing about how views work is that they're actually a hierarchy, a tree from the top of everything. So if we come over into Android Studio again, you'll see our tree is pretty simple right now. It's got a constraint layout as the root, and then it has a single text view. And if we added other layout elements to it, what happens is we start at the top and move our way down. And as we move down from that, we figure out how to draw things. Android itself uses a 2-pass process, a measure pass and a layout pass. You can learn more about this by checking out Android's website. But basically, the first pass, the measure pass, goes down through the hierarchy, figures out what the sizes of each of these views should be, and then the layout pass goes back through them and, modifies the layout based upon whatever those measured sizes should actually be. The viewgroups.layout parameters section. So we have properties here. The top ones, the layout underscore something. Like if we go to the text view, we have layout underscore width and layout underscore height. These properties tell the view that we're within special information, such as how this view should be handled, whether it should be wrapped or it should be matching the entire extent of the prior parent layout. All the properties below that have to do with that particular view, not the parent of the view. So that's an important thing to understand. So for our game engine, we can handle drawing in 2 ways. Really, we could do 3 ways, but we're not going to talk about OpenGL today. The first way is that we can draw using a view object. We can define our own view object and then go ahead and customize it to do whatever we want to. And this is great for things that are static, but not really good for games. The other thing we can do is define a special object called a canvas, which is specifically meant to be drawn upon using different draw calls. And that's what we're going to handle today. Now we can draw to the canvas in 2 different ways. One way is by invalidating things and telling Android, hey, redraw this as fast as you can. The other way we can handle it is by actually creating a separate thread. And that thread is going to draw the canvas as many times as it possibly can. That's the method we're going to be using today. Do remember that invalidating does not mean you have an instantaneous draw being called. It's going to queue the refresh, and it's up to Android to determine when that's going to happen. We're going to skip this example that we did in class last week. In this example, we implemented our own version of view and our own onDraw method. And if you remember correctly, we ended up continuing on until we got to the following case, which is where we created a view that filled the entire screen and it randomly changed the color of the screen. And the intent behind doing that was to basically show how slow the update rate is. So instead of inheriting from view, we will inherit from surface view. So why don't we go ahead and implement surface view? Surface view is going to be our threaded method for handling draws. So let's go ahead and do that. So come on over here. Let's create a new class. So go under Java, right click, new, Java class, and we want to go ahead and let's call this game view. Our superclass is going to be surface view. There we go. And everything else is fine the way it is. Let's hit OK. And we'll get our class. We'll also get some nice squiggles. It's going to talk about there being no default constructor, and we'll implement that in just a second. The next thing we need to do is, because we're going to have a thread working with this, we also want to implement Runnable. What this does is it means that we can use this class as a threaded object. Since it implements Runnable, it will have a run method. Our activity is going to actually call this run method, and this will continue to update pretty much forever until the user does something to pause or stop the application. So why don't we go ahead and do that? So let's do implement and Runnable. So now it's going to give us some stuff about how we don't have a constructor and we have not implemented Runnable. 2 things that we should be doing. So why don't we go ahead and hit Alt, Insert, and what we want to do is implement methods. specifically run void. So that's what's going to take care of our threading stuff. Anything we want to execute is going to end up being inside of this. We still have an error, and that's because we don't have a constructor. So for the moment, why don't we just go ahead and create that by going Alt, Insert, and Constructor. And we're going to just use a surface view that takes in a context. Hit OK, and that's enough for right now. Move that off, and let's continue. So as we just did, we implement the context, and we implement run. The only thing we need to do that we didn't is that run needs to be an endless loop for us at the moment, or endless-ish until playing is false. So while, we're going to have a Boolean value inside of that. We're going to do what's called an update loop and what's called a draw loop. So the idea is that we are going to continually update all the objects in our scene based upon whatever logic we decide to program in them. And then we're going to draw those objects. And hopefully the logic means that our objects are moving in some way or changing animations or states. And as that occurs, every time we draw, we're going to have a little bit of difference between each canvas object, which means things look like they're moving. Now we need to implement these methods, obviously. So why don't we go ahead and just do a void update. And let's do a void draw. Just so that we get rid of some of these errors. And then now we need a while loop, and we're going to make a variable called playing. And up here, let's do a Boolean playing is equal to false. Our Boolean so far, when I declared it over here, is just a Boolean. What we also need to do is make sure it's volatile. Why? Because we're actually going to be modifying the Boolean value from outside of this class. That is, we're going to be attempting to change it across two different threads. Not only the thread that we generate for our surface view, but also the thread that's running our main activity, which is the main UI thread. So we need to make sure that this is called volatile. Now we need to implement our pause and resume methods. These are going to be inside of our main activity. The idea here is that our main activity is going to pause things or resume them based upon what the user does. Remember that we're dealing with the life cycle of an activity. Therefore, your app is going to be paused, stopped, and potentially destroyed, and we need to handle all of that. Specifically, we need to handle dealing with the fact that we've created a thread. Now, these also need to be public so that we can access them in the main view. So let's go ahead down here. So we have update and draw. Let's add our public void pause. And this is going to be called directly inside of our pause method in our activity. And let's do a public void resume, which will be called in our resume activity as well. So when we pause things, the first thing we want to do is set playing equal false. The idea here is that we're done playing the game. The thread needs to terminate as soon as it's finished going through all of its update and draw elements, basically. Now, because we're dealing with a thread, we need to create a try loop. So try and catch. For right now, we're not going to say anything. The user doesn't need to know if things fail, so we're just going to catch it and let it be. Now, we have to create an actual thread first. So let's go up to the top and go thread and call this game thread. Now, this game thread is going to be doing all of our work pretty much for us. Now down here, what we need to do is game thread dot join. This is basically going to request that we wait until the thread has finished completing its work. And since we've set playing equal to false, it's going to finish its work and update and draw. This will be false, and then it will return, and then we'll join the two threads basically together, and we don't have to worry about anything. Now we need to deal with that interruption. So let's go to catch, interrupted, exception, E, and just follow that off with some brackets, and we're good to go. Now we need our resume. For this, we're going to set playing equal to true. We are then going to create our new game thread. So game thread is going to be equal to, here we create a new thread and we pass the class itself. Since the class implements Runnable, the class itself can do all the hard work. and then we just start that thread up, because remember, a thread does not begin unless you start it. So let's do new thread and this. Next up, we're going to do game thread.start. So now within the activity, we need to make sure that all of this stuff actually happens. And on create, we need to create that new view and set it, that is the surface view, and set it equal to what we're seeing on the screen. In the onPause method, we need to make sure that we pause things, and on resume, we need to make sure that we resume things. So let's go ahead and make all that happen. Going back to our main activity, let's go insert. Let's go to override methods, and we want pause. So there's on pause. We're also going to want on resume. So alt insert override resume. There we are for both. We are going to, of course, create our class. We need to create a new instance of that object. So let's go ahead and do that here. Notice that game view is a variable that does not have a type defined at first. That means we need to define it up there at the top. So let's go ahead and do a game view. Game view. Oh, looks like I have the game view in the wrong place. Let's move that into there. Hit refactor, and everything's fine now. Okay, so now we can continue. So here we have our super.onCreate. Instead of that happening there, we're going to do game view is going to be equal to a new game view, and I believe we have to pass in the context. So that's that. Next up, we're going to copy that, and that's going to be what we pass in here. We're not going to have a layout. So you can actually go ahead and delete this entire layout. It's completely unnecessary. Now, within the onPause and onResume methods, we're going to call our game view .pause and our game view .resume. So hopefully that makes sense. The idea is our activity gets messages from Android about our app needing to pause and resume, and we make sure that we stop or start our threads based upon what the user wants to do. Now, when handling things like getting ready to draw, the surface view itself has a thing called a surface holder. The surface holder is what we basically do to talk to the surface. So we need to make sure we access that and grab it. So running back into our game view object, let's go up here to the top and create our variable and store that. So let's do surface holder. And let's just call that surface holder. And within our onCreate, we're going to grab that thing. So let's go into here. And let's do surface holder is equal to this dot get holder. And there we have it. Let's put an equal sign in there. That might make things work a little bit better. Now next up, we need to deal with our draw method. Our draw method right now is not going to do much at all, but it is required to do 5 things. Check to see if the surface holder is valid, lock the canvas down so no one else can mess with it, clear it, draw whatever we want to, and then finally unlock the canvas again. So let's go ahead and do that. So surface holder was done there. Let's create our draw method, which is right here. Let's do this. So if surface holder dot get surface, it'll return a surface object dot is valid. Then we're good to go. Now we can start drawing to things. Let's grab our canvas. So canvas dot canvas is going to be equal to our surface holder dot get surface is going to be equal to our surface holder dot lock canvas. There we go. Alt enter to bring that in. Now we can do whatever we want to, but we really need to make sure that we unlock that thing. So let's do our surface holder dot unlock canvas and post, and we pass in that canvas object again. Now it's here that we draw. And in this example here, you'll notice that we draw a background of all black, with the first value here being an alpha value of 100% opacity. So let's go ahead and do that. So canvas.draw ARGB, we're going to do 255, 0, 0, 0. Save, and there we are. So why don't we go ahead and run this now and see what we actually get on our emulator right here. So let's go ahead and press run. And as you can see, we get nothing but black. Now you might say, George, does that just mean your app is crap? No. Let's try making a change. Let's make the red value 255 and hit run again. And you'll notice a red value. We do in fact have a canvas, and we are in fact updating it and drawing it to the screen. We just haven't done anything interesting yet. We're going to take a short break now. I'm going to cut this video up and upload it for the class, and then I'm going to start on the next video where we're actually going to use different draw methods such as points and lines and so forth to draw real objects to the screen. Thank you for watching.